afternoon. My name is Michael and my colleagues' names are Luis and Gonzalo. This is our presentation on ABS systems. During poor weather, most vehicles and motorcycles, when the driver's driving and tends to slam on the brakes, what mostly happens is tires tend to lock up and the vehicle will lose stability and end up getting in an accident. Not a problem, but most times on high speeds, it can end up to many fatalities. Our goal is to design a system to implement on these vehicles and motorcycles that can prevent the lockup at the same time bring back stability, or somehow try and cruise away from an accident, or maybe away from a wall or from another vehicle. Our goal is to bring these fatalities down because it's been an issue on a lot of vehicles when it tends to rain. Our ultimate goal is to implement these cars and manufacturers make it a law to bring all these systems in the vehicles. Also to design a very efficient, very cheap system, and also a system with a quick response. To give you a brief summary on how the system works, I'm going to have my colleague put up a picture on the screen. This is your typical vehicle. Most vehicles consist of 4 tires. On each tire, we're going to have a wheel sensor and with a tone ring. Mostly on front-wheel drive cars, you're going to have a CV axle in the front, so we're going to have the tone wheel implemented on the CV axles. We're going to have the ABS sensor drilled through the hub that be able to pick up a constant reading from the CV axle. On the back, it tends to bring hubs. On the hubs, we'll have a tone ring installed also in the vehicles, along with the ABS sensors. The system, most vehicles already come with their brake lines. Most brake lines we're going to have come back to the ABS pump, and also with the ABS sensors constantly sending the signals of each tire to the ABS pump. For an example, if we have someone driving this vehicle on bad conditions, let's say on a rainy day, he tends to slam on the brakes if he sees something coming up ahead. Most cars, the front wheels tend to lock up first. So what the computer sees, it's going to see the 4 tires with let's say a speed of 50 miles an hour. When these tires tend to lock up, it's going to see a 0. It's going to read a 0. So what its ultimate goal is to even out the speed on all these tires. So what it does, it throws intervals on the brake lines, unlocking the brakes. Even though the conductor still has his foot on the brakes, it'll throw intervals on the tires, releasing the tires. So somewhat will still be braking, but at the same time it won't lock up and the car won't tend to slide or drift to the side. Pretty much our goal is to have a small and efficient module somewhere in the engine bay, have access whenever any maintenance on the vehicle is performed.
Right, so as you see here, we want to implement this same design but for motorcycles, just because in motorcycles they have less safety features on the vehicle, obviously because you're open air, there's nothing encasing you, you don't have your airbags that act as a safety mechanism when you crash. So it's basically the same setup for the components, but for these two-wheel vehicles. So what we want to do here is make it as compact of a design so it doesn't affect any other system here. It uses the same sensors to detect the brake pressure, so you know when the ABS system is going to react in case of an accident, to give the driver control while it's braking so he can avoid the collision. Now, this is going to be a breakdown of parts that we have. As you can see, not too many parts, but you'll see the most expensive one is the ABS computer. Usually with the programming of this, that's where the price jumps up significantly. Every other part is roughly under $100, but the total system you can run up to $1,600, just because when you're messing around with these types of systems, the programming is extremely tricky to get correct, and if you change anything from manufacturer specs, you're going to have a nightmare trying to fix it. So most likely you're going to have to go back to the dealership, and they're going to charge an arm and a leg for the labor, for the reprogramming, for all that type of stuff. So just to go back and forth on what we wanted to do with this ABS system is we're trying to increase the safety in these vehicles and keep in mind that we want to keep the cost down for the system. Now, we understand that the benefits to this would be, since it's an additional feature for safety, you're going to have your insurance costs drop because of this extra feature, but you're going to be paying more also at the dealership when you purchase the car. Now, on top of the additional safety feature, it's going to be marketed more towards families and people that that safety is a critical concern for when they're purchasing the vehicle, not just the look and how fast it goes. But the downside is that you're going to be paying more just because this is an additional feature so that they can mark up the value of the vehicle. But essentially, you want to have the safety feature, especially in South Florida with all the crazy drivers down here, and with when you go travel up north, you're going to have icy conditions, icy roads, snow, so your tires are going to lock up and you're going to want this additional feature just to prevent any catastrophe from happening to you or any other drivers. And this concludes our presentation.